to blame. Oh, yeah. In my world, in my mind, always running out of time. My love.
Hi everyone, welcome to a new video. This is progress update 1 of building OpenKode, my own coding agent from scratch. So in this video, we are going to see how much I've built till now, how did I build it till now, and what were the architectural decisions taken, and what are the next steps. So without further ado, let's get started. Here's a short demo of how the agent currently looks like. So as you can see on the screen, I have a terminal one, and this is a CLI agent that I'm building as of now because this helps us keep things simple and focus on the core agentic core rather than on the UI aspects of things. So use the agent or invoke the agent some via doing something like this. Let's say open code who is Ronaldo. So this query goes to our LLM and then it starts producing the results. As you can see, I have streaming enabled as of now, and this is just computing the query and producing the results. Also, another nice thing that I thought should be added is that this input and output tokens, because as we progress ahead, I think optimizing the queries and optimizing the results is what would be very important aspect of this project because we need to produce results with as less token consumption as possible. So that's why I thought why not just use this feature that Ollama provides out of the box. You can refer Ollama's API documentation for this. It is just present with the output query in every request that it sends. The model that I'm using as of now is Quen 2.5. Like we can see here. See, the model is Quen 2.5 Coder 3B. Now let's get started with the internals of how I built this. Let's get started. So the as of now we have built a CLI and this is by design because as I said, we wanted to keep things simple right at the start and focus on the core LLM logic rather than on the UI because if I were to build a VS Code extension right from the start, I have to focus on the VS Code specific things rather than the AI specific things. So that's why we are starting with a CLI design. And as shown in the demo, you can see we have this terminal UI wherein you invoke the agent using OpenKode command and you write the query in ahead. The current architecture is something like you give the prompt, this goes to the LLM, and the LLM that I'm using is Quen 2.5 Coder 3B because it is a local model and I'm invoking it via Ollama and not a cloud provider because since this is an agentic operation, this will lead to a lot of code token consumptions. And at the moment, I don't want to spend on token consumptions. That's why I prefer using this local LLMs via Ollama. And that also leads to a lot of flexibility, I would say, because let's say further ahead, I want to do some fine tuning of models. It will be very helpful. Sure, it is a lighter model with a lesser output efficiency and a lesser quality, but still it works for learning purposes. And then once the LLM produces its output, we stream the output from the LLM to the CLI. OpenCode is currently divided into three main layers. One is this UI. UI, and I would say client is a better word because let's say today we have a CLI as the client, but further on, I want it to be a VS Code extension as well. And after that, if this project actually grows, maybe I could do something like cursor, wherein I just poke VS Code and build my own cursor, let's say. that is a far-fetched dream as of now. But yeah, so that's why one layer, the main layer would be the client layer. Next will be the agent core, wherein it involves all the agentic loops and agentic logic. And the third layer will be the LLM layer, which where we will have providers like Ollama or ChatGPT or Claude. Now, why this architecture? See, my aim is to keep open code as scalable as possible and learn a lot. So that also means that, let's say today I am learning how to invoke Ollama, but further on I want to be providing different providers like Ollama, ChatGPT, and Claude. And if today I I couple my agent code tightly to one provider, that is Ollama, I won't be able to swap it easily with ChatGPT or Claude. So my aim is to keep things as decoupled as possible so that it helps me switch between providers or clients as easily as very easily, rather than investing my time into doing all those code changes so that I can use the new client or the new provider. Now, this decoupling is achieved using dependency inversion principle. How? We'll get into it later. But for now, yeah, the main layers are the client, the agent core, and the LLM providers. And in between, we have the LLM provider request response structure, which we can formally call as the interfaces, and the agent request response structure, which is also an interface, so that the client, that is CLI or VS Code or my own IDE, can interact with just this agent request response interface, which further on interacts with agent core. This agent core will send its request and response, transformed request and response to the LLM interface, and then this interface will interact with all my different providers. This way, each layer is, I would say, decoupled from the other, because the agent core does not have to depend on a CLI or a VS Code implementation, or agent core doesn't also have to depend on Ollama or ChatGPT or Claude specifically. It can just have its business logic intact, and we have built the interfaces in such a way so that the core agent business logic remains intact, and the other implementations have to depend on these interfaces rather than the core depending on the implementations. Now, what were the important decisions taken? First one, first ones, First one was the headless AI core start with CLI and not with VS Code extension. As I said, building a CLI is much easier than building a VS Code extension because it involves a lot of learnings about VS Code extensions. And at the moment, I don't want to focus my efforts there. Rather, I would like to focus more on the agentic infrastructure. So that's why I started off with a CLI. Next important decision was the folder structure. The folder structure currently looks like this, where we have the core CLI and the shared packages differently separated. The exact structure will be shown in some time, but this is an overview. And the third important decision taken was by use dependency inversion principle in places like abstraction of clients and LLM abstraction. So, Mm. so here I spent a lot of time learning dependency inversion, what is it and how to implement it. And I would be honest here, I struggled a lot while implementing it because I understood the concept, but I was not able to implement it in code. And I used very minimal coding assistance like ChatGPT and all. And I my aim was to implement the things myself. So as dependency inversion states that uh, your code should depend on abstractions and not concrete implementations, which in simple terms means that your agentic core, that is your core business logic, should not depend on how you implement a CLI or a VS Code or Ollama API or a ChatGPT API. Your core logic should remain intact, and all other implementations should depend on your agentic core, not the other way around. So that's why dependency inversion principle fits in perfectly here, and it is also a very important software design concept. So that's why I learned it first and then used it heavily in the current architecture. The monorepo starts with two responsibilities, that is the CLI and the core for now, and the folder structure is also shown in the screen. One is the CLI and other is the core. Now this CLI can be replaced with other clients like VS Code extension and all, and that will be put in another folder, that is the client, under which we can have a CLI, a VS Code extension, or an IDE, etc. etc. The core involves this LLM, the agent, and the factory. I'll get into the details in soon, but this is how our folder structure currently looks like. Now, what were the learnings involved at this point of time? Now, from the AI perspective, there weren't as many learnings as such because we are just calling a local LLM and just, yeah, I learned about streaming, but but the learnings involved were more on the system design side rather than on the AI side. So, on the AI, I learned how to call a local Ollama API and then send prompts and receive output, stream new line, delimited JSON, and reassemble partial network chunks. Because many times during streaming, many times the response that you get is delimited by a blank line. So you have to store it in a buffer and then uh, output it to the client. So that's what I handled it in the code. We'll get into the code overview as well, code walkthrough as well in some time. The main learnings were system design learnings. That is, I used interfaces heavily over implementations. That is, as I said, I wanted to decouple things a lot so that it is easy to swap between providers and clients. So using interfaces was a must in such a case. Next, I learned dependency inversion and dependency injection. As I explained, the core business logic should be the main focus and not how the implementations are. So all your implementations should depend on your business logic and not the other way around. And next, factory composition route, because your CLI should not know what LLM you are using or what your core business logic is. The CLI should only focus that the CLI has to just invoke your agent and then it should just wait for a response and not bother about whether the uh, the agent is running a loop or is it running an ChatGPT API or anything. It should just invoke a API call to their agent and wait for the response. Similarly, your agentic core should not know what LLMs you are using. Like it should know, but it should not it should not be focused on whether you are using ChatGPT or Claude. It should just run its core business logic, that is the Ralph loop, the while loop that keeps running on until the task is done, and just invoke the LLM and get the response and give it back to the CLI. Nothing else. Similarly, your LLM should not be bothered whether your client is a VS Code extension or a CLI. It should just take input, do its thing, and give the response. That's it. So all these things are implemented firstly using the dependency inversion, and next is the factory pattern, wherein uh, in the CLI you just invoke the instance of your OpenKode agent and not the actual LLM client, LLM object, that is Ollama or Claude. What do I mean by this? I'll show you here. It looks something like this, wherein This is the this is the CLI code wherein you just create an open code agent and then uh, give it the user input and then wait stream out the response. That's it. We'll get into it in details in some time. So these were the main overview of what all I learned till now. Also, this is my first CLI tool that I built. So learned a bit about Commander library as well. That is how to, how to build a CLI tool, how to invoke it, and how to put in your sub commands in that. So that was also a tiny learning here. Now, as I explained, dependency inversion starts with a small contract. That is, the OpenCode agent depends on what an LLM can do and not Ollama itself. That is, it should stay independent of whether your LLM is an Ollama or ChatGPT or a cloud provider. So here is the main code snippet of the interface that helps us do this. That is, see the LLM provider. LLM provider is this interface in between, wherein it has two methods, that is generate and stream. Now, the generate or stream takes in an LLM request interface and then it produces the chunks in that is it streams the chunks. That's it. Your agent core only knows these things because it just uses this LLM provider interface and nothing else. So this way, your OpenCode agent and Ollama provider both depend on the LLM provider and not the other way around. And by depend, I mean they both use LLM provider and they don't know the internal implementations of each other. Up next is streaming. As I said, uh, network chunks do not reliably arrive as complete JSON objects. So that's why we need to delimit it using these slash n lines so that the buffer preserves an unfinished line until the next chunks arrives. Next is the factory pattern in action because the factory assembles concrete dependencies in one place. That is, the CLI asks for an agent and it never needs to instantiate Ollama provider. In simple terms, as I said, the CLI will just invoke your OpenCode agent and not a specific provider, LLM provider. That's it. So this is the composition route wherein in the interface you decide which LLM you need to use and then return the OpenCode agent with that LLM. That is you return this object so that the CLI does not have to know which LLM you are using. And then this is the dependency injection wherein in the OpenCode agent you give the LLM provider and then stream the response using the method provided in this LLM provider. So this way our CLI stays thin. It just has three jobs: collect the prompt from the user, invoke the agent, and display the results. That's it. Before getting into what the next milestone is, let's do a quick overview of the code that I've built till now. Now let's do a quick code walkthrough of this project. So this is the index.ts for the CLI, wherein you just invoke the OpenCode agent using this OpenCode command. So as you can see, OpenCode, you get this nice all the command information, and then you go inside load commands. Here you have two commands. One is the main one wherein you invoke the LLM, and then second is the great user sub command, which will be used such that let's say further on I want to add features or capabilities to this agent like scanning a repo or build the repo or scan some file or let's say give a summary like that is slash summarize or slash greet the user and so on. So such subcommands will come here like this, where this is the greet command which just says ask the user how was your day. Right here, open code greet how was your day. The main command is this load prompt command, wherein if you see, I invoke the open code agent and then we stream the response out along with the input and output tokens. So this is how a CLI looks like. Further on, this is the open code agent. Now this is where the game starts. That is, this is the factory pattern wherein I just create the open code agent here, and the LLM that I'm currently using is Ollama provider. Further on, we will do this to something like the user can select which provider he wants, and then we pass that to the agent, and this agent will then further on invoke that particular provider based on what the user wants. Next is the open code agent. The open code agent looks something like this. The open code agent class looks something like this, wherein it has two methods as of now, the run and the stream. The run method is basically an HTTP endpoint wherein you just uh, send the user prompt to the agent and then wait for its response and get the output together. Whereas in the stream method, you stream the outputs from the LLM. The reason these are separate is because earlier I wanted to, just invoke an agent and get the command so that I learn how to invoke an Ollama provider. And then once I built that, I stepped up to streaming the responses. So that's why I kept these two methods as of now. I'll remove it further on. So now up next is the LLM. Okay, if you see here, the return type is LLM usage, and the object that we are using is the LLM which extends or which is of the type LLM provider. Let's see what LLM provider is. Now, LLM provider is an interface inside this interface project or inside in this interface repo. This has two methods, that is generate and stream. Again, generate and stream basically do the same thing, that is take the response from LLM and give it to the agent for which further passes it on to the CLI. Generate is where you get the response together, stream is where you get the response chunk by chunk. If you see here carefully, you can see two interfaces, LLM request and LLM response. The request and response at the moment look the same, that is a prompt and a string which is of the type string, and a response which is also of the type string. Now, why this distinguish? Why to distinguish these both if they are the same? Because there are many things that the LLM should know, but the agent or the CLI should not know. That is, let's say, the user's name, or let's say the summarized context, or maybe the date and time, or whatever thing that the user specific, whatever thing is user specific and which is not required by the LLM. So, using such interfaces helps us do the request and response transformation, wherein you take in the user prompt, can convert it into such a format that is compatible to the LLM, or rather than compatible, I would say it filters out and adds a few things that the LLM needs, but the user does not need to know. Similarly, by using such an LLM response and request interfaces, you can filter out and add things that is specific to the LLM but is not required by the user, or I would say uh, that is required by the agent core and not required by the user, right? So that is why we are using these interfaces. And this LLM usage interface is another interface so that we output the input and output tokens to the user. So coming back, this is about LLM provider. Up next is the agent request. As I said, For now, agent request and response will be a simple string because these at the moment are nothing but the user's query and the output response. There is nothing much that we have added as of now. But further on, there are many things that will be filtered and added specific to each layer. That's why we are using these interfaces rather than just sending the response as is. So this was about the streaming things. And lastly, we have this Ollama provider, wherein again two methods. One is the generate for pushing out the response completely as a whole, and second is the stream method, where you just send the chunks one by one. The model used is Quen 2.5 order, and then these are the usual things for chunking and all. You can also see a shared repo in this a shared folder in this monorepo. This will contain the things that will be common to both the core and the LLM or the CLI. And as of now, we don't have any such common interfaces or types. But further on, let's see. I just created this folder just if in case we want it. Let's see how this project goes into. So yeah, this was how the monorepo is currently built, and I'm using PNP package manager for now because it helps us manage monorepos with ease. Of course, I would have used turbo repo, but let's see. Uh, if need if need comes, I will for surely shift to turbo repo. This was about what we have built till now. Up next is the next milestone that we need to achieve. That is a deterministic repository scanning. In this, I'm planning to, implement the feature wherein if you just type OpenKode scan, this will scan your whole repo, understand the important files and architecture that is involved in your code base, and then it basically creates an index kind of thing for your repo so that for your next query, it will be much easier rather than going through the whole repo at once. So let's see how this goes. This is what I'm planning. Deterministic static analysis will be a cool feature to work on next. And this is what my sprint planning, I would say, looks like as of now. Let's see how this goes. So here is what we have done till now. That is LLM streaming and integration. Next is the repo scan and knowing which language is used, which manifests are used, and which are the important files involved in this project, which are the important routes involved in this project. And later on, we can go into the AI specific things like code intelligence, ASP, symbols, graphs, and so on. That was it for today. I hope you liked the video. Do follow along if you want to see how I build my own coding agent from first principles from scratch. Thank you.